All right, so this video is going to start on page 13. We're going to start talking about power. So we've been talking about work. Well, power is the rate of actually doing said work. Okay, define the rate of doing any quantity or how fast to do it. Okay, take the quantity that you're doing and divide it by time. So therefore, power is the amount of work divided by time. So your equation would be P equals work over time. Okay, so we also know work equals force times distance. So you could say force times distance over time also equals power. And then we also know that D divided by T, okay, this goes back to like unit 1 would be your velocity. So we could also say power equals force times velocity. Okay, so there's a couple equations that we would give you here. So it honestly just depends on what you have. Okay, your units for power are going to, so units, units, if I can write, units is going to be watts, and that's characterized by a capital W. Okay, so that's your W there. Now that is your SI unit, so then standard calculation stuff, you're going to end up in watts, or you need to be in watts. Okay, another type of unit we're going to be using is horsepower. That is a non-SI unit, but a lot of people more accommodated or more aware of horsepower. So 1 horsepower equals 746 watts. This is a value that we'll give you. So that'll help in converting something to or out of horsepower. So our first example is if a 10 kilogram box is lifted up 2 meters, how much power is exerted in watts, kilowatts, and horsepower if it was lifted up in 2 seconds and 30 seconds? So in order to find power, we know power equals work divided by time. So do I have time? Yes. Do I have work? I have not figured that out yet. So we need work first. Work equals force times distance. I have a distance of 2 meters. 10 kilograms is not a force. Okay, that's just mass. But weight is a force. Okay, and if you're lifting something up, gravity is a factor. So force is the same thing as saying mass times gravity times distance. So that is your work when you're lifting something up. So my mass is going to be 10. Gravity is going to be 9.8. So remember, the reason why it's a positive 9.8 is since you're lifting the box up. You're the one doing the work. Gravity's not the one doing work here. Gravity is a factor, but gravity's not the one doing the work. If the box was falling, then you could make that a negative 9.8. And then your distance is going to be 2 meters. So that means the work is 196 joules. So now I know work. Now I know time. So I can solve for my power. So power equals 196 over my time, which is 2. Okay, and that's going to give me 98 watts. Okay, so I also want it in kilowatts and horsepower. So remember, there are 1,000 in a kilo. So if you're ever kind of confused on what should I multiply, should I divide, if there's 1,000 watts in 1 kilowatt, you basically have 98 out of a possible 1,000 watts. So 98 divided by 1,000 gives you 0.098 kilowatts. Now, if you want to do horsepower, 1 horsepower equals 746 watts, and you have 98 watts. So you have 98 out of a possible 746 watts. So divide those two, and you get 0.13 horsepower. Now we're also going to do it for 30 seconds. So we're going to see how time affects power. Okay, so work didn't change at all, so we just got to go right back into our power equation. So my work is still 196, but my time is 30 now. Okay, so divide that by 30, and you get 6.53 watts. Okay, divide that by 1,000, okay, and that'll give you 0.0065 kilowatts. And then divide that 6.53 by 746, and you get 0.0088 horsepower. So as we can see here is when you increase that time, power is going to go down. Okay, so now if work went up, I mean, you could still keep power the same, but work would have to go up as well. But in this case, we're not changing the work, we're just simply changing the time. If it takes you longer to do something, like if you did like a 0 to 60, okay, again, nobody wants a car that can do 0 to 60 in 30 seconds, okay, because that's not a lot of power. It takes a long time to do the same work that a car who can do 0 to 60 in 4 seconds, okay, so they have more power, so they can get that same amount of work done in less time, okay? So if you increase the time, generally your power is going to go down. So we're going to do some practice here on work and power. So it says, 1, how much work is done by pulling a wagon 50 meters along a level road by a force of 20 newtons applied to the handle if the handle makes an angle of 30 degrees with the ground. Okay, so what I'm doing is I'm dragging a wagon at an angle of 30 degrees. Okay, the wagon is going flat, parallel to the ground. Okay, so my angle is 30, and my applied force is 20. Okay, now the reason why you cannot just do work equals force times distance, well, I'm just going to do 20 times 50, is because the wagon is going, let me use a different color. The wagon is going this way, okay, purely horizontal. Okay, that 20 you have is not purely horizontal, so that's why you cannot just mix that with the horizontal distance, the 50 meters. You need to figure out how much of that 20 is actually going in the same direction as the wagon. So you're looking for what is the horizontal component to our triangle here. So that means you're looking for Fx, okay? How much of that force is in the x direction or the horizontal plane? So we're gonna use our cosine function, okay? So we're looking for the adjacent side. So if we wanna find that adjacent sides, we're gonna take our hypotenuse, 20, multiply it by cosine of your angle, which is 30. Make sure you're in degree mode, and you get 17.32 newtons. So that's how much force out of that 20 is actually going the same direction as the wagon. Okay, so now we can calculate work. Work equals force times distance. My force is 17.32. My distance is 50. Multiply those, and I'm going to get 866 joules. Okay, number 2, a boy's mass is 50 kilograms. He walks up a flight of stairs 12 meters high in 30 seconds. What power has he used? Okay, well, power equals work divided by time. I've got time. I don't have work, though, so I'm going to have to find it. So work equals force times distance. I have a distance. I don't have a force. So we're talking about a kid's mass going upstairs. So naturally, gravity is what makes stairs a pain, is because gravity is keeping you down. So you're fighting gravity to go up. So we're going to figure out his weight. We're going to do mass times gravity for our force, and then multiply that by distance to get our work. So we're going to take his mass, 50 kilograms, multiply it by gravity, which is 9.8, times the distance of 12 meters, and we get 5,880 joules. So that's how much work was done. Now I can plug it in my power equation. So take that 5,880, divide it by your time, 30, and you're going to get 196 watts. All right, number 3, an elevator in the Empire State Building in New York rises to the 80th floor in 50 seconds, so I'll give you time. If the height is 302 meters, there's your distance. What power must be developed in order to lift 12 people averaging 80 kilograms each to this floor? Okay, so pretty much the same problem as number 2. Okay, we're looking for power. Okay, do we have work? Nope, so we're gonna have to find it. So we're talking about lifting 12 people here. So we're going to do work equals force times distance, but we're just going to go right back into mass times gravity times distance. Okay, since we're lifting something, so gravity is a factor. So our mass is, I'm not going to just throw 80 on there because there's 12 people in there. So they're each 80. So you're going to do 12 times 80, which would be 960 for your total mass. Gravity is 9.8, and your distance is 302. So you're going to get a big number here, which is natural. I mean, you're lifting 302 meters. You take 12 people, 302 meters, that takes a lot of work. Okay, 2,841,216 joules. So there's your work. Now we can plug in. So 2,841,216. Divide it by our time, which is 50 seconds. And you're going to get 56,824.32 watts. 4, a 2 kilogram mass is raised 6 meters at a constant rate of 3 meters per second by a vertical rope. What is the power supplied by the rope? Okay, so one thing we talked about is I have a mass, I have a distance, I have a velocity. There are different ways to do this problem, but if I give you velocity, remember, power equals force times velocity. Okay, so in this case, we're lifting something, so force would be mass times gravity still, and then just multiply that by our velocity. So you take your mass, which is 2, gravity would be 9.8, and your velocity is 3. So you get 58.8 watts. So we didn't even need that 6 meters. Now, could you have used it another route? Yes, you could have. Okay, but that takes longer and it's more complicated. So this way, we're just doing force times velocity. Number 5, a 70-kilogram person runs up a long flight of stairs in 4 seconds. So I give you time, I give you mass. The vertical height of the stairs is 4.5 meters. There's your distance. We're looking for power in watts and horsepower. So we have time, we don't have work, so we're gonna find it. So same scenario, we're going up the stairs. So we're gonna take our mass, 70, times our gravity, 9.8, times our distance, 4.5. And we're gonna get a work value of 3,087 joules. Okay, so now we're gonna find our power. Power equals 3,087 divided by our time, which is 4. That gives you 771.75 watts. So there's your first answer. Now, if I want that in horsepower, I'm gonna take that 771.75, divide it by 746, and you get 1.03 horsepower. 6, how long will it take 2 horsepower motor to lift a 400-kilogram piano to the 6th-story window 20 meters above? So I gave you power this time, okay? But if you noticed, whenever we solve a power equation, we always end up in watts. So in order to use the equation, you have to be in watts as well. So I'm gonna go ahead and fix that. So my power would be 2 times 746, and that gives me 1,492 watts. So now my power is good. So I've got that fixed. So power equals work divided by time. Okay, we're looking for time. How long does it take? So that means we need work. Okay, so we're lifting something up. So work equals mass times gravity times distance. So 400 times 9.8 times 20. And we get 78,400 joules of work. Now I have work. I've got my power. So now I'm looking for time. Now I can plug in. So 1,492 equals 78,400 over time. So remember, if you're looking for a variable on bottom, okay, you can always switch these two. So take 78,400 divided by 1,492, and you get a time of 52.55 seconds. 7, a hydraulic jack provides a lifting force of 800 newtons, so I gave you force, and a speed of 0.5 meters per second. There's your velocity. What power does it produce? So remember, power equals force times velocity. So all you gotta do is 800 times 0.5, and you get 400 watts. Number 8, if a car generates 15 horsepower, well, there's power. You're in horsepower, so I'm gonna go ahead and fix it. Okay, we're gonna fix it to watts, so 15 times 746. Okay, and that's gonna give you 11,190 watts. Okay, it's traveling at a steady 80 kilometers per hour, so I can't have kilometers per hour, I need meters per second. So we gotta divide that by 3.6. So 80 divided by 3.6 is gonna give you 22.2 meters per second. So what must the average force exerted on the car due to all frictional forces? Okay, so we're just looking for force. So remember, power equals force times velocity. So our power is 11,190 equals my force, which I don't know, and my velocity is 22.2. Okay, divide both sides by 22.2, and you get a force of 504 newtons. 9, calculate the work that gravity does on the object as it slides down to the ground. Okay, so gravity is obviously pulling this ball down to the ground. Okay, so gravity doesn't really care about the ramp. Okay, it doesn't care about the distance of the ramp. Its goal is purely to get it from the top, right here, and all the way down here. Okay, so if work is being done by gravity, that means work is being pointed down. Okay, and if work equals force times distance, well, that means force has to be going down and distance has to be going down. Okay, they have to all be in the same plane. So work equals force times distance. Well, I'm talking about gravity here, so it's pulling the object down, so my force would be mass times gravity since I have a mass on the ball. So mass times gravity times distance. So my mass is 4. Now gravity is doing the work, so it's going to be negative 9.8. And my distance is, so again, gravity doesn't care about the ramp. That ramp could be 10 meters long or 20 meters long, doesn't matter. All we care about is how high or how far gravity had to take it to get from the top to the bottom, which would be that 10 meters. And since we're going down 10 meters, that's gonna be a negative 10 meters. And that's gonna give you 392 joules of work. So it is okay that that's a positive value for work. So I know gravity's working and pulling it down, but gravity's the one doing the work. Typically, when you see a negative work, that means it's typically going against the motion. Like friction would be like an example of negative work because it's going against the motion. Okay, so that will end power for that one.